Welcome back to my YouTube channel. Uh, my name is Vijay Kumar Jha and I am working as an assistant professor in an engineering college. And today I will take an example of a design of a staircase because a lot of students have passed their BTech in civil engineering and MTech but do not know how to design a staircase. So many students have requested me to give an example that how to design a staircase. So I am taking an example of a design of staircase for a single flight. Okay, it is a very simple example by which the student can relate this and can know how to design the staircase. So first of all, I am giving my introduction. Uh, this is my introduction part. I have done my BTech in civil engineering and MTech in structural engineering. And this is my research profile. You can check out my research profile by visiting the ResearchGate. Here it is my research profile, which is available in internet in ResearchGate. And after that, you can also take up my research profile at Google Scholar. This is my research profile and this is my number of publications are also given which I have worked on these topics and published so many of journals here. And also this is my LinkedIn profile. The student who want to connect with me are advised to send request in my LinkedIn profile. Okay, so this is my some contact informations, and apart from that I have qualified GATE in 2018. This is my portfolio, and I have qualified the West Bengal Public Service Commission exam, junior engineer exam in the rank of 30 in West Bengal, and also selected for doing PhD at various IITs and also in CSIR. After that, I've also qualified in West Bengal Public Service Commission for becoming an assistant professor in Government Engineering College and progressed up to interview, and also qualified the written test for Indian Space Research Organization for the post of scientist C, and progressed up to interview. Also selected for junior structural engineer at Mekon India, which is a PSU. Also selected for graduate engineer BIS, which is also a PSU. BIS means Bureau of Indian Standard, which is also a PSU. Apart from that, I am also selected for a guest lecturer in Government Polytechnic College, and also qualified various several company interview and corporate job interview. The student who want to take a mock interview can also request me to connect with me. And also the student want to take guidance from me from about the PhD interview also requested to connect with me. So today I have we can going for a we're going for a design of a staircase, and here the size the design of stair, the floor to floor height will be 10 foot, that is 3 meter, and there is only single flight. I have already told you there is only single flight. Okay, and the live load is as per IS 875 part 2, that is 5 kN per meter square, and FCK is 20 Newton per millimeter square, and FY is 500 Newton per millimeter square. This is the design details. I am taking this problem because I have taken several mock interviews of student, and I have asked that how to design a staircase, and it is my my experience is so bad. The student is not not able to tell the answer that how to design a staircase. It is designed as a simply supported beam. All the stairs, these doglet stairs, I am taking example of a straight stair, but all the doglet stairs are designed as a simply supported beam. Okay, simply supported, you can also call it as simply supported slab. Means the staircase design always taking as a simply supported. Okay, so I am giving example of straight flight. Means there is no turn, there is no 90 there is no turn is present here, only a single straight flight is there. Okay, single straight flight is there, means this single straight flight, and this is not present here. Okay, only this single flight is there here. Okay, only this single flight. Okay, so let's come to the example first. This is the example, design of staircase where the floor to floor height is 10 foot, that is 3 meter. Okay, and I've already told that it is a single slide. So first of all, I am starting from the assuming the size of riser. What is riser? Riser is this. This is called riser. Okay, this is called riser. This is called riser. This is called riser. This is called riser, and this is called thread. This is called thread. Tread. This is called thread. Okay, this is called thread. This is called riser, and this is called thread. Okay. So let the riser is 150 mm. Okay. Now there is the floor to floor height is 3 meters. So we have to select the number of riser. So by dividing 3000 with 150 mm, we are getting 20. So 20 number of risers are required. So number of threads should be number of riser minus 1. This is the formula. So number of thread should be number of riser minus 1. That is 20 minus 1, that is 19. So 19 number of thread are required. This means 19 number of thread are required. Okay. So what is the value of going? Going means this. Going means this. From this to this is called going. Okay, this in this direction called going. Okay, so total going is required is 19 into 275. I am assuming the size of thread. The size of thread is 225 mm. The size of thread is 275 mm. Okay, that means this size. That means this size. This size is 275 mm. 275 mm. 275 mm. So it's coming out to be 5225 mm. That is equals to 5225 meter. Total size of going is should be 5.225 meter, and I am also assuming the width of landing slab. This is called landing slab. This is called landing slab. It should be 900 mm. Okay, width of landing slab should be 900 mm. It is assumed, and width of landing slab is equals to width of staircase. Okay, this width of staircase also should be 900 mm. That's why I am assuming the width of landing slab is 900 mm. Okay, so I have just proportionate this size according to simple requirement, but you have to proportionate this size according to your requirement, according to your room size. Okay, I am just giving an example, that's why I have assumed these values, but in practical life problems you have to choose this dimension according to your room size. I am very much clear about this point, that you have to choose this requirement, this size according to your room size. Okay. So let start again. Then here so this is the size of the effective span, that is 5.2 clear span, that is 5.225 meter. That is this side from here to here. Okay, these are stairs. So these are the stairs. Okay, and the beam of landing with this slab is resting on the landing with beam. This is called landing. This here the landing with beam should be present. Landing beam should be present here. This is the landing beam. Okay, I'm just changing the color of the pen. Let's take it this color. So this is the landing here. So the landing beam should be present here. Here the landing beam should be present. In the slab is resting on this landing beam. So we have to find out the effective span. So 5.225 meter, 5.225 plus 300 by 2. 300 by 2 means here the landing size should be 300. Here also the landing beam size should be 300. That means I am taking center to center distance, that is 5.225, 150 plus 150. Okay, you can also take another value, that is 300 up to this 500, 5.225 plus 300 plus 300. Okay, you can also take this. So it is coming out to be 5.375 meter. If for this problem the landing beams is present only at one side. Okay, that's why I have taken 300 by 2. The landing beam should be present in one side for this problem only. But in case of practical problem, landing beam may be present in both sides, for here also, here also. But for this problem, landing beam is not present here. It is only present here. It is only present here. That's why I have taken 300 by 2 here. Okay, means only from this point to center of this beam. That's why I have taken 300 by 2, that is 5.225 plus 300 by 2, that is 5.375 meter. This is the effective span of the slab. Now Now total thickness of base slab, this is called base slab. Means if I have to draw, let's take a new slide here. If I have to draw, okay, so I'm drawing here. This is the thickness of base slab. Base slab is the inclined slab. This is the thickness of base slab. This is the inclined slab. No, this is the staircase. This is the staircase. This is the thickness of the base slab. This is total thickness of waist slab. It is called waist slab. Okay, this is called waist slab. W-A-I-S-T, waist, S-L-A-B, waist. This is called waist slab. So this is the thickness of waist slab, which we have to assume that is 120 of span. 120 of span. How we are assuming 120 of span? Because it is from serviceability criteria. Serviceability criteria of IS 456. I am assuming this as per serviceability criteria of IS 456. There is 1 by 20 of 5375, which is coming out to be here 5.375. So it is coming out to be 268 mm. That is, I am taking the overall depth as 300 mm. Okay, I am taking the round of value, that is 300 mm. Okay, so now coming to the load calculation part. So what is the weight of base slab? The weight of base slab should be d1 plus d root over of 1 plus r square by t square into 25. Here r means the riser height, which I have selected here, so 150, and t means which I have selected 275 mm. T, it is trade, okay, t, trade, side of the trade, which I earlier told. Okay, now coming to the 0.3 into root over of 1 plus 150 square 275 squared into 25, that is 25 is the density of concrete, which is 25 kilonewton per meter cube, coming out to be 8.54 kilonewton per meter. Now it is the weight of the base slab. Weight of the steps should be 25 RT by 2T. This is the formula. Okay, so 25, there is a derivation of the formula, but don't need to memorize the derivation. We can memorize this formula. This 25 RT by 2T. There is also derivation for this formula, from where it is coming, but don't need to memorize the derivation. We just memorize this formula only. Okay, so 25 RT by 2T, that is coming out to be 1.75 kilonewton per meter. This is the total dead load which is acting on the slab. Okay, that is the weight of the base slab, that is weight as well as the weight of the steps. Now total dead load is 8.54 plus 1.75, that is 10.415. Okay, now what is the total live load? According to IS 875 part 2, the total live load is 5 kilonewton per meter square, which is coming out to be per meter, which is acting per meter width of the staircase. Means 5 kilonewton per meter square into 1, that is equals to 5 kilonewton per meter. It is if I again write it, it is 5 kilonewton per meter square into 1 meter. It is meter out, and then it should be 5 kilonewton per meter. So it is acting 5 kilonewton per meter. Now total dead load is 10.415 plus 5, that is equals to 15.415 kilonewton per meter. This is total dead load plus live load. Okay, so what is the factor load here? The factor load is 1.5 into 15.415. This total load. Factor load means this is the, I am taking this characteristics load, it is working load, to the ultimate load, to design load. You can also say design load by multiplying load factor according to IS 456. Okay, so dead load plus live load into 1.5 is load factor, that is coming out to be 23.12 kilonewton per meter. I am taking this value as 24 kilonewton per meter. Okay, now coming for landing, we have to also design the landing portion of the slab. Landing means this dead load is equals to dead load. I am taking the width of the depth of landing slab is 0.3, that is 300 mm, and 25 is the density of the concrete, and 1 is the per meter width acting is the load is acting as per meter width, so it is coming out to be 7.5 kilonewton per meter. As well as live load, I am taking as 5 kilonewton per meter, that is already stated, that is 5 kilonewton per meter. How it is coming 5 kilonewton per meter square? Is 5 kilonewton per meter square into 1 meter, that is equals to 5 kilonewton per meter. So total load coming out to be 12.5 kilonewton per meter. That is, I am taking as 13 kilonewton per meter. I am multiplying it 1.5, and it is coming out to be nearly about 20 kilonewton per meter. 20 kilonewton per meter. This is the load. So this is the load factor load acting on the base slab. It is the factor load acting on the landing slab. So now we have to determine the bending moments. So I have drawn this diagram. So the effective span will be 5.375 meter. I've already told you how to calculate the effective span. So it is like this. It is 24 kilonewton per meter. Here it is 20 kilonewton per meter in slab. 20 kilonewton in slab. Now we have to calculate the reactions here. These reactions at Ra. I have already told you that the staircase should be designed as a simply supported beam, or we can say as simply supported slab. So the reactions are as a simply supported. It is a indeterminate structure, so it can be taken the reactions can be find out by taking moments at A or B. That is summation of moment at A equal to 0 or summation of moment at B equals to 0. Okay, so the RARB is symmetric loading. Sometimes load must not be symmetric, so you have to calculate accordingly what is the moment coming or what is the reaction. Okay, so now RA should be like this. This is the RA. This is the RA reaction at RA and RB. The RA and RB should be equal because the loading is symmetric. So RA RB should be equal. Okay, now coming to the bending moment at midspan. So we have to calculate. So we know that for a simply supported beam, the bending moment is maximum at midspan. The bending moment is maximum at, taking yellow. Bending moment is maximum at midspan for here. So we have to calculate the bending moment at midspan. So it is 0.9 meter, it is 5.375 meter, it is 0.9 meter. So I am taking at midspan. So accordingly, I have calculated the bending moment. I assume that you people are able to calculate bending moment, because in my interviews, whenever I am taking interview in college, because I am working as an assistant professor in an engineering college, also taking mock interviews of various candidates, they are also not able to calculate the bending moment for a simply supported beam. For an intermediate structure, it is quite difficult to calculate, but for a simply supported beam, it can be very easy. Okay, for any type of loading, because the reactions can be easily found out by taking the equilibrium equations, that is summation m equal to 0 and summation v equal to 0 and summation h equal to 0. But the students are also not able to calculate. They have done their M.Tech as well as B.Tech. Okay, so try some go for practicing some books, that is strength of material books, solid mechanics books. There is a M Chakraborty book is good for initial days, and after that you can go for Stimoshenko, which is a international book. Okay, so there are various books are available for solid mechanics. You can also go for Bansal. Okay, so because if you are a civil engineer and you do not know how to calculate the shear force and bending moment for a particular determinate structure, I'm taking determinate structure only, so it is very difficult for you. Okay, so please try to calculate this bending moment at midspan. Okay, I have calculated, and the bending moment is coming as 144.72 kilonewton per meter. So we have to design it. So this is the bending moment for we have to design. Okay, so I am taking my pen change. So I have to calculate this bending moment. Now coming to the bending moment requirement. So from this is the flexure formula as per IS 456. I think you people know about this, that how it is coming. I'm not going to detail about this. If you request me that, sir, kindly make a video that how the flexure formula is coming here, so I will try to make a video. Okay, so I am not going for this detail from here. It is coming. It is taken from IS 456. Okay, so MA equals to 0.87 FYST into D minus 0.42 XU. XU is the depth of neutral axis. Okay, so let it will be the balance section. First, I am assuming it will be a balance section. Okay, so let XU max is equals to 0.46 of effective depth. What is the effective depth? I am assuming 20 mm clear cover. That is why it is effective depth come out. What is effective depth? Effective depth means this is effective depth, means this is the center of the tensile reinforcement, and this is D, means from the outermost portion of the beam to the center of the tensile reinforcement is taken as effective depth. So I have calculated that is assuming 20 mm clear cover, 300 mm is the overall effective depth which is given in the slab, minus 20 is the clear cover, and minus 5 mm is the die of the stirrups which I have taken. Okay, you can take it 8 mm or 10 mm, whatever it may be. Okay, it can vary. So you can calculate the effective depth accordingly. So this is the effective depth, and 0.6 from 0.6. 0.6 is equals to value of XU max by D. XU max by D, the maximum depth of neutral axis for balance section. Okay, so it is taken as per IS 456, which is 0.446. Okay, so it is coming out to be nearly about, if I have actually it is if I will calculate this, take me first of all, let's calculate this. 300 0.46 into 300 minus 20 minus 5, that is equal coming out to be 126.5. It is coming out to be 126.5 126.5 mm. It is the maximum depth of neutral axis. Okay, now this is the moment. So I am equating the moment, external moment, with this. So this is the equation. So I have to find out this. So I am taking this 0.42 0.42 into 48 into 275 mm, that is equals to 275, means the 300 effective depth of this beam minus 0.42 into 0.48 into 275. Okay, so this is coming out to be 1507 mm square. Okay, now this from indirectly this is coming out to be 1507 mm square, and 0.48. Why I am taking 275 here? Can you tell me why I am taking 0.475 275? Because we know xu max by d is coming out to be 0.46. 0.46. Let it erase. Okay, so 0 xu max by d I have taken 0.46 from IS 456. So x, what is the value of xu max? Xu max should be 0.46 into d, right? So this d is taken as 275 mm. This d, that is why I am multiplying it. I am taking it here 0.8, but for this point it should be 0.46. Okay, let me make it 0.46. Okay, I have mistakenly taken it 0.48. Okay, but this value should be 0.46 here. So there is only a little bit change here. Little bit change will be there only in AST. So I have just not going to change it of the value of AST, but little bit change is occur here. Little bit change will be occur here. So this is the 0 d. Okay, this is the d. Xu max should be 0. Xu max by d is equals to 0.46. So the value of xu max is equal to 0.46 into d. So this is the value of d that I have put it here. Okay, now AST is coming out to be 1.1507 mm square. So this is the value of AST, which is coming out to be 1.1507 mm square. Now taking 16 mm 5 bars, I am taking them, giving 16 mm 5 bars, means 16 mm dia bars. So Fi equals to itna. So spacing of the bars should be this. I have calculated the spacing, that is AST by Fi into 100 into 1000. So this is the AST coming is 135 center to center. Okay, which is must be less than 3D or 300 mm. This should be less than 3D, means 3 into 275, which should be less than 300 mm. One means this spacing should be less than 3 into 275 and 300 mm. Okay, so I'm just this is very clear, that is this 135 center to center must be less than 3 into 275 and 300 mm. So it is okay. So it is okay. It is 135 center to center is okay. Okay, now coming to the distribution still. So distribution still as per IS 46 in slab where HYSD bar is used. HYSD bar is used. So it is coming out to be 0.125% of the area. It is 0.12 by 100%. It is why I am dividing with 100 into, I am taking per meter width of the slab, that is equals to 1000 into 300. It is equals to 360 mm square. It is equals to 360 mm square. Okay. Now spacing of 10 mm 5, that is 78.5 by AST into 1000. Same, this 200 to 1805 center to center is 220 mm center to center. This is the spacing. Okay, let me take some time to make it charge. Okay. So it is coming out to be 220 mm center to center. Now coming to the development length. So this is the development length formula which must be satisfied. It is 0.87 F5 by 4 tau BD according to IS 456. So 16, I am using 16 mm 5 bars, 0.87 Fy 4 tau BD. This value tau BD should be taken as from IS 456. IS 456, that is 1.2, and I am increasing 60% because it is in development bar for what? For HYSD bar. That's why we are taking a 1.6. Okay, by increasing it with 60% here. So it coming out to 752 mm. Development length should be 752 mm, which we have to provide. So I am giving development length of 800 mm, round of value. So this is the development length we have to provide. Now coming to the drawing. This is the drawing. This is the drawing, simple drawing. The drawing is very clear. If you want to zoom it, I can zoom it. Let's take this see this drawing, how I am giving reinforcement. This is the main reinforcement. Yeah. This is the main reinforcement. Niche. It is at the bottom. At the bottom, this is the main reinforcement. This is 135 center to center mm. 135 mm center to center is the bottom reinforcement, which is the main reinforcement, and this is the top this is the distribution reinforcement. These are 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 the distribution reinforcement which should be provided. It is 10 mm 5, 230 mm center to center. Okay, and this is the development length of the bar. This is the development length of the bar which must be provided. This 800 mm which I have calculated earlier. This 800 mm. This is the development length of the bar. Okay, you can also provide this slab bar up to 800 mm. 800 mm. Okay, here also the reinforcement of slab is also present here, and the beam is resting at this portion. Okay, this is the how we are going to design the staircase, and this is how we are detailing the staircase. Okay, this is the plural part. This is the we have assumed it is 150 mm and it is 275 mm. 275 mm, and this base slab is 300 mm overall depth is there, according to my question. Here some other checks are also, we can also go for other checks, that is equals to deflections. I am not giving criteria for deflection check. Deflection checks also have to perform, but deflection checks are already satisfied because I have assumed the depth as per deflection criteria, that is 120 is 120 1 by 20. From here, from the deflection criteria, I have assumed the depth is 120 of span. So it is already satisfied. So we have to not go for deflection check. Okay, we have to check that is it is a balanced section or under reinforced section, because I have taken this AST. So let's check it is a balanced section or under reinforced section. So from this formula, it is 0.36 FCK XU into B. I think you have all know about this formula. It is from this equation 0.87 Fy into AST. So let's find out the value of XU, that is depth of neutral axis. So 0.36 FCK is 20, XU is I have to calculate, and B should be taken as 1000 as I am taking per meter with the slab, and 0.87 Fy means 500 into AST. AST means what AST I have given in the slab, that is equals to 1507. It is equals to 1507. So it is coming out to be 0.36. Let give me some time. 0.87 into 5 into 500 1507 into 1507 divided by 0.36 into 20 into 1000. It is coming out to be 91 mm. 91.04, which must be less than 0.46 into 275. So 0.46 into 275 means 0.46 into 275 means, which is coming out to be 126.07. 126 is coming out to be 126.5, which coming out to be 126. 91.04 must be less than 126.5 mm. So it is okay. So I can say here from here I can say that is XU is less than XU max. That means it is what type of section it is? It is under reinforced section. It is an under reinforced section. So my design is okay. That is I have designed under reinforced section. Okay. So my design is okay. So this is the overall design of a staircase as a simple staircase of a straight flight. This is a straight flight. Okay. No changes there. So if in case of dogleg stair, there is a 180-degree turn is there. In case of dogleg stair, means like this from here to here. Okay, but for this problem only a single flight. I have only designed a single flight. Okay. So this is the overall problem. I think I will make able to clear to you. Okay, if you have any doubt, you can comment on the video. I will try to clear that doubt. And also I'm requesting you that if you have any problem in any topic, you can comment that, sir, please make a video on this topic. So I'll try to make the video on that topic. If you want, then I'll try to make a video. Okay, suppose pile design, 3 pile cap design, or any water tank design, whatever you want to study. Okay, so I will try to make a video on that. So I think I will make able to clear to you. So thank you, and have a nice day. And if you have any doubt, you can comment on the video. And also the student who want to take a mock interview for upcoming PSC examinations, that is PSC interview, Public Service Commission interview, and also for PhD guidance or any kind of PhD interview, how to give PhD interview, what are the IITs we have to prefer, what are the recent research topics are there, so you can take guidance from me. Okay, and this is obviously this is a free of cost. I am not taking any kind of charges from you. Okay, so you will able to connect with me on the LinkedIn, also on my researchgate profile, also in my Google Scholar profile. Okay, so this is all about my today's video, and thank you, have a nice day.